I'm all ready to start again. Now I gave you something to think about related to airline passengers. Now I'll confuse you even more. We go to ship passengers. That's a slightly different story though. Slightly different context, slightly different reality that we are facing. Now we are looking at the number of passengers X. And this number is now the random thing. So already here you can see it's not the same story as before. It's not just a repetition of before. It's a new situation. So it's the number of passengers, which on average are 400, and then also with a standard deviation of 40. Meaning that between 320, two standard deviations to the left, and 480, two standard deviations to the right, we have most of the situations, if I may say it like that. So in 95% of all trips with this ship, we will have a number of passengers going between 320 and 480 with a mean of 400. And we can assume that it's a normal distribution, we are told. That's the model for this reality we are facing as a ship company. Here, from time to time, where we go take this route, this is what happens to us. So, here's another question related to money. The company earns 120 Danish kroner per passenger. Calculate the mean and the variance of the profit, and calculate the chance that the profit will exceed 50K for a trip. On the other hand, how often will the profit go beyond 50K, 50,000 on a trip? We need to find the probability that y exceeds 50,000. The question is, what is y? What is y? Now is chat time again. Would you like to have a go? Why? I mean, you did the perfectly right thing last time, what I had hoped you would do. For me to make a point. What is y here? What is the profit on a trip in this, the way the situation has been described here? Would you like to try, yes?
X1 multiplied for 120. And then plus all the x's up to...
Well, what are the x's then? No, it's actually not that bad. It's a pretty good start. Actually, anyone else want to try? I mean, here, basically, I see only one x here, right? We're looking at one trip, one random trip, and we have a random number linked to this trip, namely the number of passengers. It's 1x. There is only 1x here, actually. It's just to confuse you that depending on the situation, there might be many x's or there might be only one x. I mean, the problem of before was my lack of precision in my way of setting up the story, right? If I had been more precise, I would have been explicit about the fact that there were 55 x's. But I was just loose in my... Now, actually, I'm not loose, actually. But then, as I say, that's the reality out there. You will meet this degree of looseness among your managers when you go into a company and you're going to deal with randomness. Don't expect your manager to say, now assume that you have x1 slash ... up to x55. Can you tell me the variance of the sum of x1 plus ... plus x... Your manager won't speak this language, right? He would say, I expect there will be some randomness in this. Find the risk to me. What, right? So this is a challenge to us, to take the reality into explicit numbers. The answer is straightforward here, obviously. And it's almost what you said, but there's just only the one x. Since the profit is 120 per passenger, and the random is the number of passengers, of course it's 120 times x. And then basically we're done, you could say, in this example. Then we pursue that. Now it's an exercise like you did last time with the normal distribution, right? The mean becomes 120 times 400. The variance becomes, using the variance rule where we extract a squared from the formula, 120 squared, times the variance of x, which is 40 squared. Having those two numbers, we can pursue and find what is the probability of being beyond 50,000, like we have learned now. It would be 50,000 minus this number. I think I can calculate that in my head, actually. That would be 48,000 if I do this one. On average, it's 48,000, the profit. And what about I think I can calculate also the square root of the variance. That would then be 4,800, actually. Right? The square root of the variance is 40 times 120, which is 4,800. Yes, that must be correct. And then, of course, we could take table 3, or we can take R and calculate this number. Just for finishing off, this number becomes 0.337. Should we do it in R? I'll put an example number. I forgot the number. Let's take, what is the chance of going beyond 50,000? 1 minus p norm, that's going beyond, going to the right of it, using a mean of 48,000 and using a standard deviation of 4,800. So we don't have to do the set transformation by hand if we use the p norm function like this. That becomes 33.8%. 0338. I did a wrong rounding here, I believe. So in roughly 1/3 out of trips with this ship, you get a profit of beyond 50,000. So that's how you can use things like that. Okay, so you need to think about what is the situation in the given context to get hold of the right variabilities. You need to think. We can deal with any situation, but we need to identify the situation. That's the sort of the downside. We have to think a little bit out there in the real world to actually apply these tools. I plan to skip example 7, and I'll do example 8 at the end as a teaser for what comes in my course. So George, we take a step here.